Hi there everybody, today we're going to look at interpreting histograms. Alright, so if you haven't already looked at our other lesson on histograms and frequency density, please look at that first, because obviously the skills needed for this are, I'll explain in that particular one, but I'll also try and do it as much as I can for this one as I go through anyway. It's just a bit of a recap. Right, so when interpreting histograms, remember that the frequency is the area of the bars. Alright, that's the kind of the key thing to remind yourself of. So the area is the frequency is represented by the area of each of the bars. Okay, so for example, we're going to go through a couple of these. So calculate the number of people represented in this histogram. All right, so when we're dealing with something like this, you've got to remember that top line is the area of them represents the frequency. All right, so if I'm looking at this histogram and I'm trying to identify how many people represented, then I need to work out the area of all the rectangles effectively that are there. And the only way of really doing it is doing every rectangle, as you see, every bar separately. And then, of course, adding the whole lot together at the end. All right, so let's break it down into its stages. So let's focus on A first of all. So let's look at A, which is this bit here. So the gap here is 20. And then the height here looks like it's 1.25. So if I just times those two together, first of all, it's going to be 1.25 times by 20. So that's the first bit, that's A. Then we're going to look at B. You can see I've labelled it already. It's got a height of 3, and this gap here is 15, so between 20 and 35 by the looks of it, which is going to give you 3 times 15, which is going to be 45. Then you've got C, which is 45 up to 95, so it looks like 50, and it's times by 0.5. Is it 60? Let me just double check that. So 35 to 95. Yeah, no, it's 60. All right, so yep, it's up to 60. That's going to give you 30. And then over here, looks like it's a 95. So just a gap of 5 times 2. All right, so 5 times 2. All right, so just bear in mind, obviously, what happened to me about reading the obviously graph very, very carefully. Obviously, it doesn't matter for me at this point. You know, I'm just kind of speaking out loud and talking to you guys. What you need to be thinking about is obviously how detailed you do it and how carefully you do it in the exam, because obviously you're after the marks again. We can't be affording those mistakes in the actual exam. All right. So in answer to the question, so calculate the number of people represented in the histogram. Well, we've calculated the number of people represented by each of the bars. Of course, we now just need to add the lot together. All right. So 110 people is represented in that histogram. Okay. So that kind of concept is needed an awful lot. And of course, if we're going to try and answer a further question about estimating the number of people, that concept needs to be applied, is what we're going to look at now. So like I said, sometimes we have to calculate the area of parts of a bars to provide estimations. All right, and it is just an estimate, because there's no guarantee that the exact numbers are that we calculate are exactly right, because we don't have all the information. We just have a bar that represents certain criteria. I'll explain that as we go. So estimate how many people are less than 12 years old. All right, so less than 12 years old. All right, so when we're looking at this one, you've got an age range that goes from 0 to 100. And if I'm going to estimate 12, it's going to be roughly around about here. All right, and because I'm trying to figure out the actual numbers, it's the area of that bar from 12 underneath. All right, so I'm going to highlight it now so you can see it. So you've got 12, which goes to about here, and then it goes up to 1.25. All right. So how do I work out the actual frequency? Well, the frequency is the frequency density times the class width. Well, the class width is 12. Kind of obviously establish that one, but the height is 1.25. So I'm going to do 1.25 times by 12, and it suggests that there are 15 people. Right now again, it is an estimate. We don't actually know for certain, because we know that between 0 and 12, it is that kind of that range, that gap. But we don't know exactly that's the amount of numbers, all right? So we don't know perfectly, okay? Because all we know between 0 and 20, so between 0 and 20 times by 1.25, which is, I think, 25, there are 25 people between 0 and 20. So we are estimating how many people between 0 and 12. But that's all we know. Between 0 and 20, there's about 25 people. All right, so what... You would expect 15 people to be less than 12. All right, so that's the answer to the question as an estimate. So let's have a look at how many people between 30 and 61. All right, so between 30 and 61. So this is a little bit more awkward. So I've got 30. Let's figure out where 30 is. 30 is here. So halfway between 20 and 40. And then 61 is just going to be about there. All right, so I've got this bar, or that little bit there, and then I've got this bit over here up to around about 61. All right, so let's kind of highlight it so you can see there. So that's what I'm looking for, the area of that bit. So I'm going to do 5, that's the gap of that bit, I think. 5 times 3 for this top bit. There, I'll call it A and B. So 5 times 3 for 15. And then this bit over here, well, it's 5, and then it's another 20, so 25, 26. Yeah, because it said one more, didn't it? 26 times 0.5. So 26 by 0.5, and that's going to give you 13, and then you're going to add the two together. So you've got 28 people who we estimate to be between 30 and 61. All right. So it's only an estimate because we're assuming that the people are distributed evenly in the groups, and of course we don't know that for certain. All right. So that's hence it's an estimate. Okay. Well, I hope that helps. So just kind of remember, I suppose, the key part of any kind of histogram or frequency density chart or graph like this is that the frequency is the area. Okay, can't stress it more than that, but the frequency is the area. All right, so take that away. Do go to maths-school.co.uk and do some additional practice on it to kind of consolidate it. But that's it from me. Thanks for listening.